Hello everyone, welcome to Microprocessor and Microcontroller course. In this video, I am going to discuss few multiple choice questions from the 8085 microprocessor architecture and pin diagram. So first of all, please go through the question. Intel 8085 is a dash bit microprocessor. So 8085 microprocessor is a 8-bit microprocessor. Already we have discussed that. Intel 8086 is a 16-bit microprocessor. But here the question comes under 8085. So we can write now it is now 8-bit microprocessor. So A option wrong and C and D also wrong. Only 8-bit is correct. So we can write like this, and option B correct based on the given question. Another question is the number of status flags in 8085 are. So 8085 microprocessor consists totally 5 flags. Those are carry, auxiliary carry, 0, sign and parity. So 8085 microprocessor consists only 5 flags. Those flags names I wrote here. All these flags are status flags, which explains the status of each instruction. After completion of ALU operation, based on the result, these flags affects here. If after ALU operation, if extra bit is generated, or sometimes if the ALU operation requires a borrow, then carry flag sets, otherwise it resets. And auxiliary carry. Auxiliary carry explains the carry generates from the lower nibble to higher nibble. If any carry generates from the lower nibble to the higher nibble, then auxiliary carry sets, otherwise resets. So it always explains the nibble operation. Nibble is nothing but group of 4 bits. And 0 flag. If the result is 0, then the 0 flag sets, otherwise resets. And sign flag explains the whether the result is a positive or negative. So directly it stores the MSB bit of the accumulator, most significant bit of the accumulator. If the MSB bit is 1, then sign flag becomes 1. If the MSB bit is 0, then the sign flag becomes 0. Because already we have discussed in binary data representation, MSB bit 1, then the number is a negative, and if the MSB bit is 0, then the number is a positive. So sign flag explains the whether the result is positive or negative. And similarly parity flag. Parity flag explains the if the result consists even number of ones or odd number of ones. Now we are in 8085 microprocessor. Based on the 8085 microprocessor internal architecture, if the number of ones in the result even number, then this parity flag sets, otherwise resets. So these are the internal operation of the each flag. So one of the very important concept from the 8085 microprocessor. So finally we can write how many flags here? 5 flags. So option A correct, B and C, D, these are wrong. Another question from the 8085 microprocessor, which stack is in 8085 microprocessor? 8085 microprocessor stack follows the LIFO, last in first out. Stack always follows the LIFO, last in first out, and if it is a queue, some queue registers also available, that queue follows the FIFO, first in first out. But 8085 microprocessor, the stack follows the always LIFO technique, last in first out. So option B satisfies, and remaining options are wrong here. Another question, the width of the address bus and data bus in 8085 are respectively. Just we have to find out the width of the address bus and data bus. Based on the 8085 microprocessor architecture, address bus capacity is 16-bit and data bus capacity is 8. Internally it consists totally 16 address lines. Those lines defined from the A0 to A15. And similarly, this microprocessor consists totally 8 data lines. These lines defined from the D0 to D7. So data bus is used to transfer the data, which performs the read and writing operations. That's why the data bus is always the bidirectional bus. And address bus is used to determine or find the address location of the external devices. So address bus always follows the unidirectional bus. Now based on the given question, the answer is now 16-bit address and 8-bit data bus. So we can select option A. So in this case, 8 and 16 reverse order is given. So these are wrong. Only option A correct based on the given question. Another question from the 8085 microprocessor. Memory locations, dash memory locations can be addressed directly by Intel 8085 microprocessor. So 8085 microprocessor memory locations accessing capacity is always depends on the number of address lines. In 8085 microprocessor, it consists totally 16 address lines. So using 16 address lines, the memory accessing capacity is 2 to the power of 16. So 2 to the power of 16 we can write like this: 2 to the power of 6 into 2 to the power of 10. 2 to the power of 6 value is 64 and 2 to the power of 10 value is kilo. So now it can access 64 kilobytes of memory. This one is the maximum memory accessing capacity. So every microprocessor internally it has the address bus. The memory accessing capacity of the microprocessor is always depends on the number of address lines. Let us assume if the microprocessor has n address lines, then the memory accessing capacity, MAC I am writing now, memory accessing capacity is 2 to the power of n bytes. So now here it has 16 address lines. So based on that we can write it can access 64 kilobytes of memory. So from this option A not satisfies, B not satisfies, and C also not satisfies, but option D satisfies 64 kilo. Another question: the number of software interrupts in 8085 microprocessor. So 8085 microprocessor consists both type of interrupts like hardware interrupts and software interrupts. Here I am writing HW hardware and SW software interrupts. 8085 microprocessor has 5 hardware interrupts and 8 software interrupts. I will write those names. Hardware interrupts are trap, RST 7.5, RST 6.5, RST 5.5 and INTR. So all these are comes under hardware interrupts. From this trap is a non-maskable interrupt, so highest priority interrupt, and these are maskable interrupts. So INTR is comes under lowest priority interrupt. The priority order is defined in this order. Highest priority interrupt is a trap interrupt, and next priority is given to the RST 7.5, later 6.5, later 5.5, and later INTR. So INTR is the lowest priority interrupt. Trap, name of the other name of the trap is RST 4.5. It's also called as RST 4.5. Here I wrote the number 7.5, 6.5, 5.5, 4.5. These numbers explains the memory address location. So like interrupt address location, because these are comes under vectored interrupts. So we can write now trap and RST 7.5, 6.5, 5.5. All these are comes under vectored interrupts. If these interrupt has a fixed memory location, but INTR does not consist the fixed memory location. That's why it is a non-vectored interrupt. So these points are important because generally we can expect the questions from the hardware interrupts, these type of questions. And similarly, I won't write about these software interrupts. This 8085 microprocessor consists totally 8 software interrupts. 8086 microprocessor consists 256 software interrupts, but in 8085 it has only 8 software interrupts. Those interrupts are defined from the RST 0 to RST 7. So RST 0, 1, 2, 3, 4, 5, 6, 7, up to 7 we can take. Totally it has 8 software interrupts. All these interrupts are vectored interrupt. Every interrupt has a fixed memory location. And to identify the fixed memory location, that the interrupt memory location of the 8085 microprocessor, some standard procedure is used. That procedure I will explain now. RSTN. So this N is one number. This N explains the address location, that interrupt address location. To find the address location, this 8085 microprocessor follows the standard procedure. That procedure is this N is multiplied by 8, whatever the N number, that multiplies by 8. Now it gives the result some number. That number is defined in terms of a decimal. That's why I wrote the base 10. Later we have to convert this decimal number into hexadecimal number. Then it gives the exact address location of that particular interrupt. For easy understanding purpose, I am taking one example. Let us take this trap 4.5. Trap RST 4.5. This example I am taking now, N is equal to 4.5 is multiplied by 8. Then the result it gives the 36. The 36 number is a decimal number. Then try to convert into hexadecimal, because the address location is always defined in terms of hexadecimal form. So now if you convert 36 into hexadecimal, divide by 16, 16, 2 is 32, remainder is 4, then which gives the 24H. or we can write like this 24 base 16, or we can write 24 H explains the always hexadecimal representation. So the memory address location or interrupt address location of the trap interrupt is 24H. Similarly, we can find the address locations of the remaining interrupts also. These numbers explains the address locations. Here also I wrote RST0 to RST7, totally 8 software interrupts. Each interrupt has a fixed memory location. Those locations are 0, 8, 10, 18H and 20, 28H, 30H, 38H. Those locations are fixed for the each interrupt, and each interrupt occupies the 4 bytes of memory. So this concept generally comes under the interrupt structure of 8085 microprocessor. Here I explained the complete concept because sometimes we can explain the questions from this concept also. But based on the given question, here number of software interrupts we have to select 8. So option B correct, A and C, D are wrong. If the question is comes under hardware interrupts, then we have to select 5, option A. But here this is comes under software interrupt, so option B correct based on the given question. Coming to the next question, identify the non-maskable interrupt in the following. Just now I have explained non-maskable interrupt is a trap interrupt. So generally we can write like this: trap is a non-maskable interrupt. Trap is also called as RST 4.5. It's also called as RST 4.5. Now here RST 4.5 option is given, so directly we can select option A, and option B, C and D, these are wrong. The next question, in response to the RST 7.5 interrupt, the execution of the control transfers to memory location. Just we have to identify the interrupt memory location of this RST 7.5 interrupt. So just now I explained one standard procedure. Whatever the number here, this number is multiplied by the 8. So 7.5 is multiplied by 8. Now it gives the 60. This number is a decimal number, that is a 60. Then try to convert into hexadecimal. So to convert the hexadecimal, just divide the given number by the 16. 16 3 48. The remainder is 12. So the 12 we have to write in terms of hexadecimal format, that is C, and 16 zeros 0 and 3 here we have to write the remainder. Then note on this remainders from the bottom to top direction, then the result is now 3C. So this is hexadecimal data, that's why we can write this 3C H. H explains the always hexadecimal. So this one is the address location, and this address location we have to write like this 003CH, because always we have to write in terms of 16-bit format, because the 8085 microprocessor consists totally 16 address lines. The complete address is defined in terms of 16 bits. So the 16 bits in terms of hexadecimal, it gives the 4 digits. The 4 digits address location is 003CH. Then go through the options. This one is wrong, and 2CH is also wrong, 34 is also wrong, and option D correct, 003CH. So based on the given question, option D correct. Another question, which of the following is both level and edge sensitive? So here a simple question is given, which of the following is the both level and edge sensitive? So which interrupt follows the both type of triggering? Generally in 8085 microprocessor, all hardware interrupts are nothing but external interrupts. So these interrupts follows the triggerings, right? So generally every process, generally triggering is two types, edge triggering and level triggering. And again, level triggering and edge triggering is classified into another two types, positive and negative. But here we have to write edge triggering and level triggering. And based on the microprocessor architecture, trap is the highest priority interrupt. It is a non-maskable interrupt. It follows the both level and edge triggering. And similarly, another interrupt is there, that is RST 7.5. RST 7.5 follows the edge triggering. Sometimes we can expect these type of questions also. Which interrupt follows the only edge triggering? And this interrupt follows the positive edge triggering also. So which interrupt follows the only positive edge triggering? Then you have to select RST 7.5. Now the question is comes under level and edge sensitive. That's why we have to select which interrupt? Trap. So trap is also called as RST 4.5. Based on the options, we have to select any one. And the remaining interrupts, RST 6.5, RST 5.5, and INTR. So all these are comes under level triggered interrupts. So now based on the given question, trap is the correct answer. So option A wrong, option B wrong, and option D also wrong. We can select directly option C. So based on the given question, option C correct. In this video, just I have explained only few questions, few multiple choice questions from the 8085 microprocessor architecture, pin diagram and programming part of 8085 microprocessor, 8086 microprocessor, 8051 microcontroller are explained in MPMC course, microprocessor and microcontroller course. Download the app from the following link. The link is given in description, so please go through that link and download the app. This is one of the basic course and the important course for all competitive exams. Those who are interested to take this course, please download the app and take the course from the directly app. Amdoor Educational Academy provides the all type of courses like competitive exam courses and B.Tech subject semester courses. So those who are interested to take those courses, download the app and go through the courses. Thank you so much for watching this video.